65 is on systems of nonlinear equations. So we've done this before. You did it in Algebra 2. You actually did these exact questions in Algebra 2 because I was lazy and I just copied them over. But we'll handle this. So number 1, so it says x squared plus y squared equals 25. And 4x squared plus 9y squared is equal to 145. So first of all, can you identify these shapes? What are these? A circle. What about the bottom one? Not quite. It's not quite a circle because we have a 4x squared and we have a 9y squared. If they were the same number, it would be. What? It's an ellipse. So if you found a circle intersecting an ellipse, how many possible solutions could I have? 4. Now, could I have a circle intersecting an ellipse like this? Sure, I could have 2. Or I could have a circle intersecting an ellipse like this, right? I could have 1. Or I could have a circle and an ellipse and have 0 solutions. Okay, I don't know about 3. Could we get 3? I think we could if it just touches there and then it, oh, I just did 5. Wow, that can't be 5. We could only do 4. What are we trying to do here? How could I get 3? I bet we could. Yeah, if it like touches here and then just barely touch, I don't know. We'll have to think about the 3. But maybe not. All right, so let's try these. So we have x squared plus y squared equals 25. We have 4x squared plus 9y squared equals 145. So what we're going to do is we're going to multiply through by like 4 or by -4 or -9. So I'm going to multiply through by -4. So I get -4x squared minus 4y squared equals -100. And then I'm going to put the other equation directly below it so I can do the elimination method. So when I add straight down, I get 5y squared equals 45. So y squared is equal to 9. So y is equal to plus or minus 3. Once I have the values for y, I go back in to find the values for x that go with them. Okay, so a lot of times I'll just do like y equals 3, and then I'll find it for just 3. So if I plug it in, I have x squared plus 3 squared is equal to 25. I made these so nice. So x squared is equal to 16, so that means x is equal to plus or minus 4. Well, what that means is 4 can be x and 3 can be y, or -4 can be x and 3 can be y. Do you see that if I plug in a -3, do we get the same thing? Yeah, so I could also have 4 and -3 and -4 and -3, right? Easy. Those are the 4 points that we would intersect at. And you can graph it on Desmos. I probably wouldn't use a calculator to graph it. What's the drawback of using one of the graphing calculators? I mean, you can use a graphing calculator, but see how it's kind of, I mean, you have to, if you try to solve for y here, you'd have like 25 minus x squared under a square root. So you'd have like 2 functions. You'd have plus or minus the square root of. So it's a little bit hard with a graphing calculator. So if you want to use Desmos and check your work, you can. All right, so number 2. This one's kind of nice for us because we got 25y squareds, right? So I'm going to multiply the top one through by a negative. And when I add straight down, I get 32x squared is equal to 169 minus 41, 128. Is that right? So if I divide it out, I get x squared is equal to 4. So what's x? Yep, plus or minus 2. So we go back and we plug in. So plug into any equation. So if I have 4x squared, I'm going to do 4 times plus or minus 2 squared plus 25y squared is equal to 41. Okay, so I just went ahead and put in the plus or minus 2 because I see that when I have a positive 2 or a negative 2 and I square it, I get the same thing. So what do we get when we square this? So we get 4 times 4, 16, plus 25y squared is equal to 41. Can you guys already tell what it is without doing any work? Okay, so subtract the 16 over. 25y squared is equal to 25 now. Can you tell what it is? Divide by 25, so I get 1. So I get y is equal to plus or minus 1. So my answers are 2, 1, 2, -1, -2, 1, and -2, -1. Okay. I would say that you can write things as plus or minus 2, plus or minus 1, but make sure you have all 4 of those if you do that. Sometimes it's just like a parabola intersecting a circle, and maybe it only intersects like twice, right? So it's not necessarily always 4 answers. Okay. Next up, what do we have? What shapes? We have a line and a parabola. A parabola that's up and down, right and left. What direction is it going? A parabola that's opening to the right. Yeah, so we have a right-facing parabola, and we have a line, and they would intersect in 2 points. Maybe less. All right, so this one's where it gets a little bit trickier, because we can't just line them up and do elimination. I know you guys love elimination. It's not always elimination. Sometimes we have to do substitution. So is it really easy? Like, notice how we have one of them solved for x already? If you have x is equal to all this stuff, we're going to plug in all this stuff for x. So I'm going to have 2 parentheses y plus 1 squared minus 6 plus y is equal to 3. So I did substitution. So I get 2. I'm going to FOIL out y plus 1 minus 6 plus y is equal to 3. Can I do 2 steps in one, or are you going to cry? So if I FOIL out y plus 1, I get y squared plus 2y plus 1, right? So I'm going to multiply the 2 in. So I get 2y squared plus 4y plus 2 minus 6 plus y. I'm going to subtract the 3 over 2. Okay, we got y squareds and y's. If we can get them all on one side and we can factor, that's good. So I have 2y squared plus 5y. I have 2 minus 6 is negative 4. Minus 3 is negative 7. Here comes Chuck. There he is. Factor. So when we factor, we have 2y and y. What do you guys think? Yeah?
2y plus 7 times y minus 1.
You got it. You guys all have that? So what do we get for y? It's kind of gross answers. Y equals 1, that one's a nice one. Y equals negative 7 over 2, which is like negative 3.5 if you want to write it as a decimal, but I'm going to leave it as negative 7 over 2. So then what are the x values that go with those y values? So if I plug in y equals 1, I don't want to plug it into the top one. Do you guys remember this from Algebra 2? Okay, you want to plug it into the one that has the smallest degree. Because if you plug it into something with a bigger degree, sometimes you get those extraneous solutions, right? Extraneous solutions are extra solutions. So we don't want to get the solutions that don't actually work in both equations. Okay, so when choosing which one you're going to plug back into to find the point, like the rest of the point, go with the one that's the smaller degree. So it's also much easier, right? X plus y is equal to 3. And we know y is 1. What's x? 2. Okay, a little bit harder, but think of it like negative 3.5. So if I have x plus negative 3.5 equals 3, I add that over, yep, so I get 6.5, which Kinsey's going a step further. I love it. She said 13 over 2, so we're going to have x equals 13 over 2. So our answers then are 2 comma 1, right, x comma y, and 13 over 2 comma negative 7 over 2. Those are the 2 answers. Because we added the 3.5 over and we got 6.5. Well, that's like 6 and 1/2, right? Which is 13 over 2. Like 6 times 2 plus 1. Or you could leave it as 7 over 2, so add the 7 over 2 over, so you'd have like 3 plus 7 over 2, which is 6 over 2 plus 7 over 2. You could do it that way as well. All right, next up, number 4. Circle and a parabola, right? This one could definitely be 3. Do you guys see how this could be 3 answers? I don't know about the ellipse and I don't think an ellipse and a circle could be 3. But this one could be 3 answers if you have like the circle and then the parabola like that. No, I was trying. I guess you could, yeah. So if we, I guess, yeah, that does make sense. Yeah, we could do that. That would work. Good thinking, Hallie. I was having trouble visualizing that third one. All right, so Here we go. We're going to plug in, well, we could do substitution, and we technically do have y equals. Okay, let's kind of think through this problem, though, because I've done this both ways, and one way is nicer than the other way. Okay, let's do the nicer way. So what if so don't write anything, just look up here. What if I took all of this and I plugged it in for y there? Do you see that I would have to FOIL out 1/2 x squared minus 26 by itself? We don't want to do that, right? That seems complicated. Okay, to me, I think it would be easier if we could solve for x squared. Because if I could get the x squared part by itself, right, in the second equation, or in the top equation, doesn't matter. But if I got x squared by itself, then I could replace the x squared altogether. Like, I don't have to, like, square it out or anything. Does that make sense? So, let's try to solve for one of the x squareds. So, if I solved for, you know, the one with the fraction, I would have y plus 26 equals 1/2 x squared. I'd end up getting 2y plus 52 is equal to x squared, and that's fine. So then in our other equation, we would replace the x squared with that. So I'd have 2y plus 52 plus y squared equals 100. So I'd have y squared plus 2y, and if I subtract the 100 over, I'm going to have negative 48. So then I factor. So I get y, I have 8 and 6. Which one has the plus? The 8 or the 6? Because one of them has to be plus. The 8. So I get y is equal to negative 8 and y is equal to 6. So then I go back in and I plug in the one that has the smallest degree. So I'm not going to go all the way up to this one. I'm going to go to this one. Okay. So when I plug in negative 8, I think I need more room. This is what you guys always hate when I just am like, insert blank page. You do have additional notes, right? You could flip to the additional notes. So I have y is equal to 1/2 x squared minus 26. And what do we get? We got y was equal to negative 8 and y was equal to 6.
Yeah.
So let's say we plug in the y equals negative 8, 1. We have negative 8 is equal to 1/2 x squared minus 26. We can add the 26 over and we get 18. Multiply the 2 over, we get 36 is equal to x squared. So x equals plus or minus 6. So that's 2 points. That's 6, negative 8, negative 6, negative 8. All right, then we plug in the 6. So we get 6 is equal to 1/2 x squared minus 26. We add the 26 over, we get 32. We get rid of the 1/2 by multiplying through by 2. We get x is equal to plus or minus 8. So that means we also have 8, 6, and negative 8, 6 as well. Those are our 4 solutions. Okay, feeling pretty good with that? All right, so last thing. Yeah?
So like if it had 3 solutions, would it turn out that like one of them would be undefined and that's how we know we only have
It's usually one where it's like x squared was like 0 or something. That's usually when it ends up being 3, because like taking the square root of 0 only gives you one answer, not 2. You know what I'm saying?
Yeah.
All right, so number 5. So which of the following conic sections in standard form, or write the following conic section in standard form by completing the square. So what kind of shape do we have? We actually have already done this, right? Can we do it again? So we have 4x squared plus 8x plus 8y squared minus 48y plus 28 is equal to 0. So I'm going to get all my x's together, and I'm going to get all my y's together, and then usually I get the number to the other side. So I'm going to do equals negative 28. So I have my x's, my y's, and my number. And in order to complete the square, we need like a 1x squared or a 1y squared out front. Remember that? So we pull out the 4. And we pull out the 8. Oh, I gave you such nice numbers. You're so lucky. And then give you those fractions that I was doing with polar coordinates. So fun. All right, so I got to divide by 2. So divide the 2 by 2 and square it. So 2 divided by 2 is 1, squared is 1. So I put that here. And then negative 6 divided by 2 is negative 3. Negative 3 squared is 9. I put that here. But remember, I don't put a 1 and a 9 over here, because that's not really what I added to both sides. Okay, so I really actually added like something heavier, right? It's like if you have the teeter-totter, this is really heavy over here, because we really added 4 times 1, and we really added 8 times 9. Not 4.1, but 4 times 1. So we need to add 4 and 72. So we get 4 times x plus 1 squared plus 8 times y minus 3 squared is equal to what number? 48. Again, so nice of me, man. Can you tell what shape it is? It kind of looks like a circle right now, but why is it not a circle? Yeah, you got to divide out by that 48, and those numbers, like your a squared and b squared, aren't the same number, right? So I'm not going to the right and left the same amount as I'm going up and down. So if I divide by 48, I get a 1. So what shape is it? Oh, so close. Not a hyperbola, though. It's an ellipse. That's correct. Oh, I can't talk and write. So we get that. It's an ellipse, because the plus, right? If it was a minus, it's a hyperbola. So we have that. So it says, find where this shape intersects the line y equals x minus 4. Okay, I personally don't want to use the one that has fractions. I would probably use, like, this one, or I would use the one before that. I don't know. You can plug it in wherever. So if you have y is equal to x plus 4, replace your y's with x plus 4, right? So let's say I do that here, right? If I plug in y is equal to x plus 4, what do we get? So I'm going to have 4 times x plus 1 squared plus 8 times x plus 4 minus 3 is x plus 1 squared. Is that right? Equals 48. How nice. Do you see how they're the same? We have the x plus 1 squareds. That means we have 12 of the x plus 1 squareds, right? Do you see what I'm saying? And we divide by 12. And instead of foiling it all out, we're like, I'm not going to foil. I'm not going to take the then factor. I'm going to avoid all that. Yeah, I can just take the square root. It's kind of like when we used to do completing a square, like in Algebra 2, we would get everything like as something squared. We take the square root. So that means that we have x plus 1 is equal to plus or minus 2. And then we subtract the 1 over. So this is 2 values for x. What are they? Negative 3 or not 3. Negative 1 plus 2, which is 1. Once we have that, we go back here. We plug in negative 3. We get 1. So I have negative 3 comma 1. And if I plug in 1 for x, I get 5. So 1 comma 5. Those are the solutions. So we had an ellipse that was intersected by a line, and it crossed in 2 spots. Easy enough? All right, let me stop there.